in this problem, we're looking at current, and we're trying to calculate the surface charge density, that's this symbol, of the belt that's transferring charge from a point to a sphere. And in order to do that, first we need to look at the surface charge density formula, which is going to be Q divided by A. And that means that we need to figure out what charge is, and we need to figure out what area is. Now, in order to figure out charge, let's look at the current. Because current, I transferred it to millicoulombs per second, because that way we can understand that it's actually Q over T. All right? So I equals Q over T. And because of that, now we could say to ourselves, all right, what's the time? Well, because both of these are after seconds, let's just say T equals 1 second. We choose any second, but I'll just go with 1 second. Now with that, we can go ahead and say at 1 second, this is just going to be 84 millicoulombs, and this is just going to be Q over 1 second. I mean, we can kind of see how Q will be equal to 84 millicoulombs, right? The point is that now we have our Q, and we're going to take a look at A. So after 1 second, this little belt has moved 41 meters, and this might be 38 meters wide, and so therefore we can calculate the area after 1 second, right? Because T equals 1 second. This is just going to be 41 times 0.38. But we could set up the equation first, and we'll just basically say that surface charge density is equal to 84 millicoulombs divided by the area that we would get, which is 41 meters times 0.38. And so when we plug that into our calculator, we should get something like 5.4 millicoulombs over meters squared. Yeah, that would be the answer.